Hello, everyone, and happy Conference Monday. So, today for your video activity. In this video, we have notes on one side and kind of two questions I'm going to go through with you on the other side of this paper. Um, and then you guys are going to have some slides to do on the Nearpod to prove that you were paying attention and understanding the lesson. So, our learning goals today, and go ahead and pause the video to write this down, are one, I can decide whether or not two polygons are similar based on their angle measures and side lengths. So if I gave you the side lengths and the angle measures for two polygons, you'll be able to tell me if they are similar or not. Two, I can explain whether or not congruent corresponding angles are enough information to prove that two figures are similar. So if I was to only give you the angles and not the side lengths, is that enough information to prove if they are similar or not? Um, so just kind of a quick reminder that similar in math does not mean the same thing as similar in ELA. Similar in ELA means that they have things in common. So, for example, a square and a rectangle are similar because they both have four side lengths and four right angles. But a square and a rectangle are not necessarily similar polygons in math because it all has to depend on the scale factor and being proportional. Um, so that's kind of be going to be our like focus today is paying attention to whether it's similar in math. You're going to be given shapes that have things in common, but are they actually similar figures? So two polygons are similar when every angle and side in one polygon has a corresponding part in the other polygon. So every angle and side has to have a corresponding part. That basically means that you can't have a rectangle and a pentagon being similar because the pentagon has one additional side, one additional angle that won't have a corresponding part on the rectangle. Um, but then you will have to be able to identify, well, which side of two rectangles correspond to each other. Okay, so the other thing that makes two polygons similar, all pairs of corresponding angles have the same measure. So if you have two shapes that look similar, but their angles are not the same, automatically not similar shapes. So if you're given two shapes with different angles and asked if they are corresponding, automatically the answer is no. The angles have to have the same measure. But then also corresponding sides are related by a single scale factor. So they have to be proportional. If one side is multiplied by a scale factor of 2, another side is multiplied by a scale factor of 3, that's not the same scale factor, that's not proportional. Each side length in one figure is multiplied by the scale factor to get the corresponding side length in another figure. So when we were dilating last week, we knew that we were able to multiply the side lengths, the coordinate points, multiply them to by the same scale factor to dilate them. Well, if you are multiplying by two different scale factors, you're not doing a proper dilation. It's not going to give you a similar figure. When you So sorry. When you multiply one of the side lengths by the scale factor, that corresponding side on the other shape is going to be that the product of the side length times the scale factor is going to give you that other side length. So these are like the three big things that you guys need to know to determine if polygons are similar. Does every angle and side have a corresponding part on the other polygon? Are all corresponding angles have the same measure? And do all of the corresponding sides relate by the same scale factor? Are they proportional and multiplied by the same scale factor? So our summary question here, are these pairs of polygons similar? So we can see that they are both rectangles, so they do have the same angle measures. All four angles are 90 degrees. We just now need to check to see if they have the same scale factor. So if I'm looking at A to B and E to F, I need to do EF was given to us was 3. AB given to us is 4. So I need to put them over each other from A to B to E to F. The scale factor is 3/4. Okay, so I did the new side length over the original side length. I cannot simplify 3/4, so that is the scale factor there. Now I want to check my other side given to us. So if I look from E to H is 2, A to D is 3, and put those over each other, we can say that the side length AD to the side length EH, the scale factor is 2/3. And you can't simplify that either. These are two different fractions, two different scale factors. They are not similar because there's two different scale factors going on. So we want to say the rectangles are not similar because the scale factor the scale factors for all the parts must be the same. So these are not similar rectangles because the side lengths did not dilate proportionally. 4 to 3 is not the same scale factor as 3 to 2. So they are not similar rectangles. Okay, down here we have these two polygons. They have the same side lengths, which just means a scale factor of 1. So 3 to 3 is a scale factor of 1, 2 to 2 is a scale factor of 1. But notice that these angles are not right angles. This is one of the things that 8th graders do make mistakes on. The angles do not change. The angle measures do not change when you dilate a shape. So these are also not similar, and we're going to say the sides all correspond. And we'll mention the scale factor of 1. So with a scale factor of 1, but the quadrilaterals are not similar because the corresponding, I run out of space here. Corresponding, that's one word, angles do not have the same measure. Okay. So those are kind of the notes for today. Please make sure that you get those written down, and we're going to use that information to complete the next part of this video, the backside of your paper. Let me go ahead and find where that is on my screen. Maybe? Of course, something's blocking that. Hold on. I'm going to pause my video so I can find this. Okay, I found it. So on the back side of your paper, you should see something like this. This is problem A on the back side. So we are going to kind of discuss what the two people say about these shapes and determine who we agree with, if we agree with either of them. And we are writing incomplete sentences, friends. We are writing incomplete sentences. So here we have a square, two, 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 two. They have the same sides and right angles. Here we have a rhombus, two, 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 but different angles. So Priya says these polygons are similar because their side lengths are all the same. Claire says these polygons are not similar because their angles are different. Do you agree with either Priya or Claire? Explain your reasoning. So go ahead and tell me who you agree with on the Nearpod. Okay, and then based off of the notes that we just took on the front side, we said that the angles have to be the same in order for them to be similar. I cannot dilate this square and get this rhombus. The scale factor for the sides is 1 again, but I cannot dilate by the scale factor of 1 and it changed the angles. Dilations do not change the angles. So we want to say that we agree with Claire because when you dilate a figure, it does not change the angle measures. We can add on there the angle measures must be the same for them to be similar. You could also add in there and say Priya is correct in the fact that all the side lengths have the same scale factor, but the angles do have to be the same. Okay, so pause and get this down if you need to. And we're going to move on to the next one. So the next one that we have is similar to the first example in the notes. Jada says these rectangles are similar because all of the side lengths differ by 2. So she's saying from 4 to 6 is plus 2, from 2 to 4 is plus 2, 4 to 6 is plus 2, and 2 to 4 is plus 2. Lynn says these rectangles are similar. I can dilate AD and BC using a scale factor of 2, and AB and CD using a scale factor of 1.5 to make the rectangles congruent. Then I can use a translation to line up the rectangles. Do you agree with either Jada or Lynn and explain your reasoning? So let's first talk about Jada. So Jada says these rectangles are similar because all the side lengths differ by 2. Well, when we talk about the change in side lengths, it has to be multiplication, not addition. So just because all the side lengths add 2 to get the new rectangle, that's not what makes a similar figure. The scale factor is multiplication. And if we talk about Lynn, Lynn is correct in her math. To go from AD to EH and BC to FG, you have to multiply by 2. 2 times 2 is 4. 2 times 2 is 4. And her math is correct again, going from AB to EF and DC to HG. 4 times 1.5 is 6. 4 times 1.5 is 6. But she forgot that the scale factor has to be the same in order to for them to be similar. You can't dilate using two different scale factors. So we agree with neither of them. So we want to say we we want to say neither Jada nor Lynn is correct. Jada thinks you can add the scale factor when you are supposed to multiply. Then we can say Lynn's math is correct, but you can't have two different scale factors. Okay. Let me try and get, there we go. Neither Jada nor Lynn is correct in this one. These are not similar rectangles. So on the next part of your Nearpod, you are going to have to um, look at two trapezoids on a grid. Use the grid lines to kind of help you determine side lengths a little bit. But also pay attention to the angle measures. The measures are not given to you. So kind of look at it. Do they look like they have the same angle measures? Or the diagonal lines, use like what we did when dilating to figure out the length of the diagonal lines. You'll have to tell me which trapezoids are similar on the next page. Then you are going to have to do a multiple choice of three problems telling me you're going to be given three statements. You have to tell me if when each statement is true. So, kind of thinking back to our um, rectangles and this parallelogram on the notes page here. Of course, my background. On the notes page we just did, we said the scale factor is 1, so you can have corresponding, or you can have congruent shapes be similar, it's just a scale factor of 1 times 1. So that's kind of something that we didn't really talk about. And then the last one, it's going to give you a picture and you have to explain why you know they are similar. So we just did a whole bunch of these are not similar because you're going to have to tell me why the two shapes are similar. If you have any questions today, please let me know.